This is a YouTube video of Ptolemy's model of the universe. Ptolemy was, um, this was AD 140 and I don't think this is quite an accurate representation of Ptolemy's model, but it gets a few things right. You can see the moon circling the Earth in there, and then it's got Venus coming in and out closer and further from Earth. I'm sorry, that's probably Mercury. Might be Venus. I'm not sure which one's which. And this one is Venus probably. And then it's got the sun going around the Earth at a regular rate. That would be once every 24 hours. And then it's got Mars, Jupiter, Saturn, and that was it because they didn't know anything about Uranus or Neptune back then. The Copernicus model, or heliocentric. Helio is after the sun. The other one was geocentric with the Earth in the center. This one's heliocentric with the sun in the center. You can see Earth going around the sun, and inside there Mercury and Venus, which are closer than the sun. And then where's Mars? There's Mars. Mars and Jupiter, Saturn, and this one's got Uranus and Neptune in it as well. I'd say the big difference between these two models is that uh, this model, the heliocentric model, doesn't have any unexplained motions. There aren't any invisible things making the planets go in and out closer and further from the Earth. Instead, you've actually got them going around circles around the sun, and they're not their motion does still go further and closer to Earth, but it's not due to some weird path they're taking around the Earth. It's just due to the two planets' relative position within a larger context. So for a little review, heliocentric means sun-centered, and geocentric means Earth-centered. And Earth-centered is Ptolemy's model, who was AD 140. And sun-centered was originally published in a book by Copernicus, I guess. And he was, let's see. Well, Copernicus believed everything was in perfect circles. There was another guy that recognized that they were ellipses, Kepler, and then over time we had Newton kind of come up with the laws of gravity that explained Kepler's laws. But there were a series of scientific reasons why these guys kind of came up with these things. Ptolemy, for instance, and Aristotle, they said surely the Earth isn't turning that fast, because they were thinking about the wind, which if the air stayed still while the ground moved beneath it, it would be like 900 miles per hour. And then Copernicus, he thought everything went in perfect circles, because really the planets that he could see really did go in perfect circles. Kepler based things on the observation of comets, and Newton realized that the objects on the surface of the Earth and the uh, objects out in space were obeying the same rules, same laws. So that was what happened there. In between Copernicus and Kepler, chronologically, I think, was Galileo, and his big contribution was he saw those telescopes that all the sea captains were using and said, hey, let's point those at the sky. So he learned a lot about um, the mountains on the moon, and he spotted some satellites around Jupiter and other things like that. Another point I can make about these two things. The geocentric had a moving origin. Moving origin. So the Earth was moving around the Sun and being plotted as our 0, 0 point, and that creates an issue because then all of the other objects look like they're moving when they're not. So the origin, which is labeled 0, 0, is actually moving itself. The heliocentric has a stationary origin, and when your origin is stationary, then you uh, don't have no, let's call it um, no unexplained motion. If your origin is moving, then you may have unexplained motion.